dynamic and local variable. So let's move on. Dynamic and local variable. So in the previous video we have talked about the thing that is so important topic about the C's memory structure, and in this lecture we are going to learn about dynamic and local variables. So let's move on. So variables, as we have studied about the variables, now we are going to classify the variables. Now we can say that variables has been classified into three categories: dynamic, local and global. So here in this video we are going to learn about our topic dynamic and local variables in this video. So first of all, let's see that what is the meaning of dynamic and how it works. Then we will watch about the local variables, and after that we will learn about the global variables. So let's move on to the dynamic variable. So types of variable used in C language, that is so important topic, as C compilers provide facility to reserve location in the main memory in two ways. So there are two ways. Okay, there are two ways that C compiler provides facility to reserve location in the main memory. And what are these? These are before execution, that means compile time, and the second one is during execution, that means execution time or the run time. So if you say what is the meaning of execution, that any program is going to be run, that is called the execution. So before execution means that when I'm just writing the codes, okay, and not start to run my code, and that is known as before execution, or we can say compile time, okay. And during execution means when I'm just running my code, that is the execution time or run time. So C compiler provides facility to reserve location in the main memory in two ways. That is before execution, that means compile time, and during execution, that means run times or execution time. So let's move on the dynamic variable, and that is so important things. So what we have learned here is that variable has been classified into three categories, that is dynamic, local and global. And we are just going to learn about the dynamic now. So let's move. So, in C language, variables can be created even during the execution of the program, and that is what the meaning of dynamic. So, we can say that a variable which are going to be created even during the execution of the time, that is the runtime, we can say. And when we are creating a variable during the runtime, during the execution time, then that variable is known as a dynamic variables. Now, the second point saying is that the variables created at the execution time or the runtime is referred to as a dynamic variable, and that is what we have learned now. The third point is saying that, and it is so important point, all the dynamic variables are allocated in the heap region. As far we have talked about the heap region in the previous video of C's memory structure, we will learn about the program code, global, heap and stack in the previous video. So if you forgotten that things, then you might go and see the C memory structure, and you can got that all the point. So the third point is saying that all the dynamic variables are allocated in the heap region, and that is so important point. All the dynamic variables are allocated in the heap region. In which region? Heap region. So a dynamic variable is going to allocate in the heap region. And the final point is saying us that a dynamic variable can be created with the help of the predefined function named as malloc or calloc. As we have talked about the things that a dynamic variable can be created during and using the function during the execution time or the runtime, and with the help of function, that is malloc and calloc function. So this is very important point. So what we have studied here is that point by point, that is in C language, variable can be created even during the execution of the program, and the variable created at the execution of time or the runtime is referred to as the dynamic variable, and all the dynamic variables are located in the heap region, and dynamic variable can be created with the help of predefined functions named malloc and calloc. And this is what the dynamic variable means. So in C language, variables created before the execution of the time, that is the program, or we can say compile time, can be of two types. So what we have learned here is that we have learned the types of variable used in C language. That is, C compiler provides facility to reserve location in the main memory in two ways, and that is before execution time, that means run time. Before execution time, that means compile time, and during execution time, that means execution time or run time. So, even though we have classified before execution time into two ways, into two types, and that is local and global variables. What we have classified during execution type into one type, that is dynamic variable. So if we say during execution time, then only refer to as a dynamic variable. That is the during execution, or that means to be saying execution time or runtime. So a dynamic variable can be called as the execution time or the runtime, because it is going to run during the execution. And what here is saying is that in C language, the variables created before the execution of the program, that is the compile time, can be of two types, local variable and global variables. So what we have studied here is that about the dynamic variables. Now we are going to learn about the local variables. So let's move on. And its properties, so defined and well defined features to be executed, and we need to focus on these things, that what is the meaning of the local variable, what is the meaning of dynamic variable, and what is the meaning of global variable. So one by one, I'm just dealing all the topics of the variables and its types. So let's look at the local variables and its global variables in the previous. So in the next video we will learn about the global variables. So let's look at the local variables. Local variable. Okay. So what we have studied in the dynamic variable. What we have studied. We have studied that in C language, variable can be created even during the execution of the time, execution of the program, and that is what is known as the dynamic variable. Or we can say execution time or runtime. That is the dynamic variable. But in local variable, a variable declared within a pair of opening and close curly braces are referred to as the local variables. All local variables are created on the stack region and also possess the properties of the stack. What we have studied in the dynamic variables, that all the properties, all the process properties of in a heap region. That is, all the dynamic variables are going to allocate in the heap region and not in the stack region. What in the local variable, that all local variables are created on the stack region, and this is so important point. So this is what the difference between, we can say, local variables and we can say dynamic variable. In dynamic variable, we have learned that the variable created at the execution time or runtime is referred to as a dynamic variable, and all the dynamic variables are allocated in the heap region. That is the, we can say, the C's memory structure. That is the C's memory mapping. That is in the heap region. It means that in heap region, all the dynamic variables are is going to be stored, and we have also studied about the dynamic variables, that it can be created with the help of a function named as malloc and calloc. And we will study about the malloc and calloc function in the very good topic, that is dynamic memory allocation, which will come in the next video, or I think that after the next, we can say that it is so important point for creating a dynamic variables in C language. Now, so what we have studied about the local variables is that a variable declared within a pair of opening and close curly braces are referred to as the local variable. So here, variable is declared that is within a pair of opening and close curly braces, and that is known as local variables. Now, a local variables can be created on the stack region. So all the local variables are going to be created on the stack region and also possess the properties of the stack. So let's move on the example that is so important about the local variables. So let's see. We have used the two header file, that is studio.h header file and conio.h header file here. Studio.h header files means the standard output input header file, and conio header file means control input output header file. Now we have included this file here in this C program, and we have included this conio file here in this C program. And what we have considered here is that we have used the main function whose return type is void. After that, we have opened the curly braces of main. Now, I have declared two variables I1 and I2. I1 and I2 of integer type. So its size will be 2 byte, and size may be changed according to the system. If it is 32 byte, then it will be 2 byte, and if it is 64 byte, it might be 4 byte. Okay. Now, after the declaration of the I1 and I2, we have opened the curly braces. And what the local variable says is that, what is the meaning of local variable? A variable declared within a pair of the opening and close curly braces are referred to as a local variable. So here you are saying that we have created two variables. We have created two variables, that is I1 and I2 of integer type, and it is opened and closed here. So this is the local variable. I1 and I2 is referred to as a local variable. Okay. If I consider this I3 and I4 as a variable of integer type, then again a curly braces has been opened and closed. Therefore, I3 and I4 is also a local variable within this curly braces. Now again I have used the I5 and I6 variables of integer type. Again this is a local variable because it is following the rules that a variable declared within a pair of opening and close curly braces. With a pair of Within a pair of opening and close curly, and that is so important point. And all the local variables are going to be created on the stack region and also possess the properties of the stack. And this is what the meaning of local variables. So here we have studied that the integer I5, I6, I have declared a variable I5 and I6 of integer type, and it is a local variable. Okay. Now again I have open and closes, and again I have declared I7 and I8 as a variable of integer type. Again this is a local variable. So these all are the local variables, because we have open and closes the word curly braces for it. So these all are the local variables. So this is the example of local variables, and after that we have just focusing on the closing function of the main, and we have closed it. So this is what local variables are, and this is the way of declaring the local variables. So these all are the local variables. I1, I2 are the local variable. I3, I4, I5, I6, and I7, I8 are the local variables. So moving on the more example, here you are seeing hashtag include studio.h header file, hashtag include choreo.h header file. So these two are the header files. As I have told you that it stands for the standard input output header file, it stands for control input output header file. Now what is the meaning of this main function? So it is a function that is going to declare as this within the curly braces. Now its return type is void, means empty. There is no return type of this function. I have opened this function, then after that I have declared I1, I2, I3, I4, I5, I6, I7, I8. So these all are the local variables because it follows the condition that a variable declared within a pair of opening and close curly braces are referred to as a local variable, and that's why these all are the local variables. I1, I2, I3, I4, I5, I6, I7, I8 all are the local variables. Very important point to be noted down, that always local variable are declared at the top in a opening and close curly braces. And this is so important point, that whatever you are going to declare, that should be within this curly braces, within the curly braces, within the curly braces, within the curly braces. Okay, and that is what going to be a local variable. If this is within the curly braces, then this is the local variable. If this is within the curly braces, then this is the local variable. If this is within the curly braces, then I1, I2 is going to be the local variable within this curly braces. Okay. So this is the life scope. We will study about the properties of local variable too. Now, properties of local variable, and this is so important topic and most interesting part of the local variables, and we can say very well. So moving on these properties of the local variable. Let's look at the properties. That the properties possessed by a local variable are as follows. So, life period or lifespan, this is our first property of the local variable. The default initialized value. Second property of the local variable, and third, accessing. How we can access any local variable, and that is so important thing. Now, moving on the first properties of the local variable, that is life period or lifespan. So let's move on the life period or lifespan of the local variable. A local variable is created or allocated within its own opening curly braces and dies or deallocate with its own close curly braces. So this is now the first point that I have told you. As you are seeing here that this is a variable I1, I2. So this is the local variable because it is within the curly braces. Now here you are seeing the life scope of it. That it is started from here and ends here. So after this point, I1 and I2 is not a local variable. So its life is within this curly braces, within this curly scopes. And I3, I4 life is within this curly braces. I5 and I6 life is within this curly braces. I7, I8 is life, it's within this curly braces, and not out of this curly braces. So it will be alive within this curly braces, within this curly braces, close curly braces. I5 and I6 will be alive within this curly braces. Okay. I3, I4 will be alive within this curly braces. I1, I2 will be alive within this curly braces. So this is the life period or we can life scope of a variable. So this was the first point of the local variable. Now moving on, we can say that hence local variables are accessible only within its own opening and close curly. That is what the meaning of local, or we can say life period or lifespan of local variables. So let's move on the thing that we are going to get you for the example that's so important in C language, that is the life. How I'm just going to explain you about the life period, the lifespan of the local variable. Let's look at. So this is the hashtag include studio header file and Conio header file. So I have told you about the standard input output header file and Conio control input output header files. Now after that we have declared a main function whose return type is void means empty. Now after that I have opened the curly braces. So if I ask you that what is the life period of I1 and I2, then we can say that it is within this curly braces. Okay. If I say that what is the lifespan or the life period of this I3 and I4, then you must have to answer that it is within this curly braces. So I am just going to elaborate it or describe it. Now I have declared I1 and I2 of integer data type. Now after that I have uses the CLR function whose work is to clear the screen. After that I have uses the printf function whose work is to print something on the screen that I have uses within this double quote. That is, I am declaring I1 is equal to percentage d format is specified, I2 is equal to percentage d format is specified, backslash and for the new line. After that I have given I1 I2 here. So it will print the value of I1 I2. So it is a fact. Now after that I have opened the curly braces again. For this local variable I3 and I4, which is within whose life period or you can say lifespan is within this curly braces. Now after that I have printed I3 equal to percentage d and I4 is equal to percentage d, the new line then. So whatever the value is going to be print here is the value of the I3. Whatever the value is going to be print here is the value of I4. Now after that I have uses the printf function I1 equal to percentage d, I2 is equal to percentage d backslash and new line. So we can say that here I1 and I2 exist because its life period is within this curly braces. So its life is remains. So it is not going to die here. What if I say, if I am declaring I3 equal to percentage d, I4 equal to percentage d, then its life has been died here, because life span, or we can say life period of this I3 and I4 is within this curly braces and not out of this curly braces. Therefore, this is not going to be printed on your computer, because the life span, or we can say life period of I3 and I4 is in within this curly braces and not away, or we can say not out of this curly braces. Therefore, I3 is not going to print anything. I4 is not going to print anything, because its life period, or because the life span is within this curly braces and not out of this. But the life period of I1 and I2 is within this and not out of this. Therefore, I1 and I2 is going to be printed here, but I3 and I4 is not going to be printed here. What it is going to print here, because its life period is within this range. So this is what the life period, that is the property of local variables, or we can say variables. So moving on the explanation of this. Here, abstract work on the principle of last in, first out. And this is what so important topic. Hence the variable created last die first. Okay? And the variable created first die last. And this is how it works. It works on a stack mechanism. Okay? Now moving on the second property, that is default initialized value. So if we say that if a local variable is not initialized explicitly at the time of declaration, then it is initialized implicitly by a value in garbage. So this is so important point. If you not initialize the local variable, then it is going to be initialized with an implicitly by a value that is garbage. So you must have to initialize the value. You may be initialize it, otherwise it is going to carry its own garbage value, and that is so important point. That is the default initialized value of this in, and that is the property of the local variable. So here look at. So here I have used the hashtag including studio.h header file, which is the header file of C language, conio.h header file, which is the also a header file of C language. Now I have included these two files here. So studio.h stand for standard input output header file, and conio.h stand for control input output header files. Now what is the meaning here is that we have included two files here which help us to call our printf function, whatever the function that is required here. After that, I have used the function, that is main function, whose return type is void. After that, I have opened the curly braces, and in that I have used the two variable whose return type is int, whose data type is int. So I have declared I1 and I2 variable whose data type is integer. After that, I have used the clrstr function whose work is to clear the screen. After that, I have used the printf function whose work is to print whatever on the screen. So whatever I have given in the within the double quote, that is going to be print here. But we have not initialized the I1 and I2. Therefore, the value it will get here, and the value I2 will get here, will be the garbage value. That will be implicitly value by the C language, by the compiler of the C language. So here the value I1 is going to be the garbage value given by the compiler, we can say system of the C language, and I2 value is the garbage value that is given by the C language. So this is the default initialized value of a variable. So moving on the last properties of a local variable, let's look at. So all local variables are accessible within its opening and close curly braces. So this is so important point in the properties of a local variable. So let's look at an example of it. Here you are seeing a hashtag. We have used the header file, two header file, that is studio.h header file, conio.h header file. Studio.h header file means standard input output header file, conio.h header file means control input output header files. Now I have declared, I have used our header file here because I want to use printf function, and printf function is within this header file. Therefore, I have to declare this header file. Now after that, I have used the main function. Okay, I have used the main function whose return type is void, so it is not going to return any value. After that, I have used the open curly braces. Okay, and in that, I have declared two variables I1 and I2 of integer data type. After that, we have used the CNR function whose work is to clear the screen. Then we are using the printf function whose work is to print whatever is within this double quotes. So I have printed I1 is equal to percentage, I2 is equal to percentage, then new line. Then I have you open the curly braces. So we can say that I1 and I2 life period is within this curly braces. I3, I4 life period is within this curly braces. Okay. So, and also one most important point is that we can access, how we can access this I1 and I2? Through this, through the variable address, through the variable name. So, when you wanted to access your variable, you have to give only your variable name. And this is the accessing of a variable. This is the properties of the variable. So, I am accessing I1, I am accessing I2. And because the default initialized value says us that if you not give any value to the variable name, then it will initialize this value implicitly. That is the garbage value given by the C. So here the garbage will be given here. Here the C will provide you the garbage value. So I1, I2 will be the garbage value because we have not initialized, because it will initialize default. So default initialize will occur here. After that, you are seeing here that we have used again I3 and I4, which is a variable whose return type is integer. After that, I have used the printf function. What is to print whatever is within this double quote. So I have declared I3 is equal to percentage d. Percentage d is the format specified which helps us to replace the value of I3. Okay. Replace the value of I3 means whatever the value I3 contains, it will be replaced here. I4, whatever the value I4 contains, it will be replaced here with this format specified. After the new lines, So here you are saying also about the life scope. Life scope you can say life period. Here the I1 and I2 life period is larger than I3 and I4 life period. You can also compare it. So here I3 and I4 is going to print. I1 and I2 also going to be printed down because its life period is larger than I1 and I4. So I1, I4 life period, or we can say life span, is within this curly braces, and I3, I4 life period is within this curly braces. So here if you are looking this, that we are using the function printf whose work is to print whatever the variable contain. So I1 is equal to percentage d, I2 is equal to percentage d, backslash n, backslash n. So we can say and refer to as here is that I1 is the variable, so the value is going to be stored in. I2 is the variable, so value is going to be replaced here. So we can say that the life period of I3 and I4 is not going to be printed here because its life period is within this single quote and not out of this single we can say curly braces. So if we say that I3 and I4 is a variable, so its life period is within this curly braces and not out of this, therefore I3 and I4 is not going to be printed here. So this is what we can say, this all are the properties of the local variable. So thanks for watching. धन्यवाद.